Good morning or afternoon, Year 11. These are the solutions to the Extension 1 Preliminary Assessment Task 2 for 2023, and it's the Summary Aided Task. I just want to say before I go through the solutions, overall, I was so proud of everyone. You guys have really put in a lot of work for this task and have done really well, okay? Don't get upset if you are not particularly happy with your mark. You're only in Year 11 and you've got a long way, a lot to learn before the HSC, and you will improve a lot. Okay, so let's have a look at the solutions. I'm not going to talk through all the multiple choice solutions, but they are here. The first one was C, and you can see I've just drawn a graph of my function x squared minus 25 and looked where it's less than or equal to 0, and it was below the graph. Looking at 2. We were given a number line, and it says, which equation best represents the above solution? The answer is A. There's a couple of ways you could have done it. I just tested some points in there, and I tested 0, and I tested another point down here, minus 3, and found out where they both worked. That's probably the best way to have done it, is to work through systematically and tested each of those points. Number 3, the family of 8 seated randomly in a circle around a table. It did say probability, so your bottom line of your solution is going to be unrestricted. It's sitting in a table. There's 8 people, so 8 minus 1, which is 7. So it has to have 7 factorial on the bottom. So that would have ruled out nearly everything. The family of 8, we're looking at the 2 youngest members sitting together. So when we're looking at that solution, and what we're going to have a look at is the 2 that are stuck together are going to be one group. So we've basically got 7 groups sitting around the table. So 7 of those 7 groups, we go 7 minus 1, which is 6 factorials on the top, and those 2 youngest members can sit either way. So it's going to be times 2 factorial, hence the A. Okay, the graph of the function, where does it have one of these things below? Well, the first thing I would have looked at is the bottom line. We know that x minus 4 can't equal 0, so x cannot equal 4, so straight up that would be my vertical asymptote. So that was a fairly simple one. And our last solution is going to be C. Now, I'm not going to go through all of that, but what you needed to do to find the constant term was to work out your general term of that expansion. I've worked it through, and then I've equated my powers. So when I got down to my most simplest form up here, I said, well, I wanted the term where I had a constant. That meant a constant term has no x, so I want x to the 0. So I've just gone 12 minus 4x is 0. Work that out, it was 3, and pop that back in. But you can work that through. The answer is C. There's your solution. I want to have a look through the next part. But overall, the multiple choice they weren't difficult, and you did really well generally. So good job. Okay, so I'm going to have a look at the solutions for question 6. So let's talk through that. Overall, this first one I think was done fairly well. The people that did make mistakes were just very silly little mistakes. So whenever you're needing to work out a solution where we've got an inequality, you need to graph the solution. There are still a few people that are not graphing it. If you don't graph the solution, you're going to end up with the wrong region of the graph. Okay, because the inequality may not go that direction for each of our solutions, so we need to graph it. Now, you can't find numbers that multiply and to 3 and add to 8, so you're going to need to use a quadratic formula. And people did a couple of funny little things in here. So when I popped in my quadratic formula, you were given that on your formula sheet, so you could easily have popped it in. I ended up with this part here. I am not happy with that as an answer. You know how to work with surd, so you need to simplify the root 52. Now, be really careful. Root 52 is 4 times 13, which becomes 2 root 13. So I ended up with minus 8 plus or minus 2 root 13 over 2. Now, a lot of people nearly got to that point, but what you needed to do was to divide that 2 into both the 8 and to both the 2. So you ended up with minus 4 plus or minus root 13. And that is a little minus in there. So that's what I was after, and they're my zeros of my graph. So that's what my parabola looks like. Oops, sorry. Just lost it there. Oops, there we are. That's what my parabola basically looks like. So it's a positive parabola. They're my zeros. And it's asking me where it's less than or equal to 0. Where my function is less than or equal to 0 is below the x-axis. So I want between these two values. So my solution is the value, over here in red, and there should be a minus there and a minus there. So minus 4 minus root 13 is less than x, is less than or equal to minus 4 plus root 13. This is a stock standard question. You need to really know how to do these, and you should all be able to do that, because that is not an extension 1 question. It's more of a, I'd say it's more of an advanced question. So if you haven't got that correct, you're going to go and practice that sort of question so you get good at those. So I looked at, you needed to have all of that for full marks. You got 1 mark if you got the correct roots but the wrong graph region, or you got 1 mark if you got the wrong roots or the correct graph region. Anything else, and you didn't get a mark for that, okay? The next one. Now, I wasn't as happy with this question. I thought more of us would have got this one out. So we want to talk through this one. Now, there's a couple of ways to do a question like this. And a lot of you are wanting to solve it. The way that you might have done in year 10 or in your advanced course is you want to just multiply both sides by x plus 3. Now, you can't do that because there's an inequality sign in there, and we don't know if that sign needs to change because we don't know if we're multiplying or dividing by a negative. So in order to get rid of that, I'm going to do it the algebraic way first. I want to multiply both sides by the square of the base. In multiplying by the square of the denominator, I'm getting rid of any negatives. So I'm not having to stress about flipping this inequality when I divide. So what I've done is I've multiplied both sides of my inequality by the square of the bottom line here. In doing so, I end up with this. So the term on the bottom line basically disappears with one of those squares on the top. So I've got an x plus 3 times by a 2x plus 5 left on the top, and that's going to be less than x plus 3 all squared. So I want to expand the left and I want to expand the right hand side. So let's do that. So we're going to end up with 2x squared plus 5x plus 6x plus 15 is going to be less than x squared plus 6x plus 9. And then I want to move that all over to the one side of the equation. And when I do that, what I end up with is x squared, by neating up the x squareds, plus 5x plus 6. And that's going to still be less than 0. Now what we're going to do now is graph this parabola. Now what I want to make sure that you understand is when we're finding solution algebraically, the graph that we get is not a graph of that original function. It's just a graph that allows us to find the solutions to that particular function. So let's quickly draw that graph. Let's factorize to start with. I'm going to go x plus 3, x plus 2. So what we'll end up with is zeros at minus 3 and at minus 2. It's a positive parabola. So our solutions are going to be less than 0. So those points there are going to be open, and we want the value that's down below the x-axis. So our final solution is going to be between minus 3 and minus 2. Now that's the solution if you're going to work that out algebraically. Now I'm not going to do it by testing the signs, but what you would have done would have been looked at the main values, and you would have said, well, x can't be equal to minus 3. What other main values could we have? And you're going to test along those values. And a few people did it that way. Personally, that's the way I like to do it, and that's the way I've got my class to do it. If you're good at algebra, it's pretty foolproof, that method, as long as you understand that that function that you've drawn at the bottom is not a function that we have at the top. Okay, it's just one that we can use to find that solution. So overall, that was done fairly well. Those that had a good crack at it, but it's something that you need to understand, and it's, again, a stock standard HSC question. So if you did not get that out, you need to go and do some work on that. So 2 marks are awarded if you got that all correct. 1 mark if you got the correct roots but got the wrong region on the graph. There wasn't many people who did that. 1 mark for the wrong roots with the correct region. Again, not many people that did that wrong. I think if you did it, you got it right. And there was a couple of people that tested values and got it right as well. So those are the ways that you could have done that one. Okay, this one over here, the last one on that first page. X minus 1 squared times x minus 4 squared is less than or equal to 0. Now, I wasn't looking at it as the multiplication of two different positive functions. We weren't testing that, but you could have done it that way. And a couple of people in Miss College's class looked at it that way, but my class have not done that yet. So what you'll see, it's a degree 4 polynomial. We're looking for where it's less than or equal to 0, and you've got 2 lots of double roots. A couple of people did some silly things and thought that was a difference of 2 squares. It is not. It's just saying that that's happening twice and that's happening twice. So our zeros are at 1, 1 and 4, 4. So they're doubles, but what happens is when you've got roots that are doubles, they bounce at that point. Okay, so you get a turning point when they're double roots. So positive quartic, 2 lots of double roots means it starts up here. It's going to bounce at that first one. It's going to go down and bounce at that second one. So we're going to end up in this quadrant up here. So I was looking for where it was less than or equal to 0. It is never less than 0, but it is equal to 0 at x equals 1 and x equals 4. And that was a solution that I was after for that one. 2 marks if you got that right. 1 marks if you made a mistake with either the roots or the graph. So again, that was not done very well. And again, stock standard question is something that you guys are going to need to practice a little bit. Let's have a look at the next one. Okay, majority of us got this first part out. We're looking at this function, 2 over x minus 1 all squared. And the first part was saying, identify any horizontal asymptotes. I think a few people just forgot what horizontal was. That's horizontal. So what values could we get? We could get y equal values. Okay, we can't get x equal values for that because x equal values would be vertical. And that was one thing that people did wrong on this one. Or the other thing that people did wrong was just give me a number. Don't give me the number 1 or the number 2. You need to specify and be more specific. What is equal to 1 and what is equal to 2? So there's various ways that you can find horizontal asymptotes. The first way I did it, the way that my class may have done it, was we've done the advanced course already, where we divided by the highest power on the bottom line, and we ended up with looking at what happens as x goes to infinity, and we've got the y-axis as, sorry, the y equals 0 or the x-axis as an asymptote. What you could have done was had a look at the bottom line, f of x is x minus 1 squared, and look at what happens as the function goes to positive and negative infinity. And what happens there, we then say if that happens, if our function there does go to positive and negative infinity, and we're looking at the parabola, then our inverse is going to have the x-axis as an asymptote. So that was one of the rules that you had on your notes that you learn in class, and that would be one that I would say would be a good one. So the answer I was after was either the x-axis or y equals 0. Nothing else would have suited that solution, and 1 mark for your correct answer. Identifying any vertical asymptotes. There are asymptotes that go up and down. They're our main ones. They're the ones that we're going to look at the bottom line. Generally, x minus 1 cannot be equal to 0. So x cannot equal 1, and that is a vertical asymptote. Don't say 1. You need to give me a specific. I'd also prefer that you didn't write this here, that you didn't tell me x is not equal to 1. Yes, that's the case, but what does that mean? That means there's a vertical asymptote at x equals 1. I would prefer to have that, but if you did do this, I marked you right for that as well. Okay, now it says sketch the function on the axis below showing intercepts with the axes. Now, what I would have done, and people did various things, is I would have drawn the function on the bottom line to start with. It's probably the easiest way, is to have a look at what a half of x minus 1 squared looked like. And that looked like this, and it cut at a half. And then what we're having a look at is, well, we know our asymptotes, because we've asked those in the top 2 questions. We're going to have an asymptote that is at 1. And that's happening at 1 because we had a 0 at 1. We also have the x-axis as an asymptote. We would then, again, depending on how you did this, if we looked at the graph of the function on the bottom line to start with, I had a half as my y-intercept. If I make the reciprocal of a half, I end up with 2. So my new graph cuts at 2. The other thing you might have noticed is that our function up here is never ever going to be negative because we've got a positive number on the top line and we've got a square on the bottom line. So we're always going to be positive. So your function should never be below the line here. And likewise, if you had have drawn the parabola, we were always in the positive section as well. So we would have been positive. So here's our graph. So to get full marks, your graph needed to look like mine over here. You needed to show both asymptotes and you needed to show the y-intercept point to get the full marks. That was generally done fairly well. A few people were trying to draw hyperbolas and draw another part down here instead of this top line. You need to really know your rules, and I still recommend drawing the denominator's parabola first and looking at what's happening. And then you can see that the sign of the function is always positive, so yours has to be positive, and that's going to be another foolproof way of getting that correct answer. You got 1 mark for a near correct solution if you were missing one thing, and I think I was fairly nice to people in this section here, but overall, majority of us got this one out, so I was really happy. Okay, let's have a look at the next one. The next part just said state the range. So I may have written error carried forward on a few of you. I got the range from your graph there. The range is the y values. Some people put domain, so just be careful that you know what range is. It's an advanced maths thing. So my range is y needs to be greater than 0 was the answer I was looking at for that graph. If you had a different graph up above, I've read the range off yours and checked that forward, and you may have got an error carried forward. So fairly well done, that one was. Okay. Now, this one. Now, this question is difficult, and I have put this one in here for that reason. It is a past HSC question. So if you had gone and worked the past paper questions, then you would have maybe seen this before. Majority of you, I'm assuming, haven't seen it before, because I don't think many of you worked those past paper questions. In the HSC, it was not done well, and I have marked this one quite strictly, and I'm looking at a few particular points. I think we had, out of everybody, 3 perfect answers and a couple of near perfect answers. So it says, the diagram below shows the graph of the function g of x, and you can see that on there. No, the darker writing is mine. It says, using the same diagram, draw a sketch of the reciprocal 1 over g of x, showing all asymptotes and intercepts. So in order to get this correct, you needed to show all of those asymptotes and intercepts and show them correctly. So what I was looking at for was, so there was more than 2 things, okay? I'm looking for, I think there's about 4 things I'm looking for. So I needed a vertical asymptote at a half because we had an intercept or a 0. So that needed to have an asymptote. I was looking at a horizontal asymptote at minus a half. Now, the original function only used the asymptote along here from the y-axis going forward. So my reciprocal is only going to need that asymptote really along this line here, along y equals a half. So there's 2 asymptotes I was looking at. I was looking for the y-intercept. The y-intercept was 1, so our new y-intercept is 1 because the reciprocal of 1 is 1. And what I was also looking at is the asymptote here that you were given. When you're given an asymptote of an original function, the inverse, sorry, not the inverse, wrong word there, the reciprocal has an open circle at where the asymptote cuts the x-axis. So you needed to have that open circle, that 1 and the 2 asymptotes, and your graph drawn in correctly as well. So most people got this part of the graph here, right, in the positive x direction. So the graph needed to change direction, so it sloped this way to start with, and needs to slope the other way, and it needs to go along the the asymptote y equals a half. So most people got that bit right. This part here, you can see where my cursor's moving here, was done okay. A lot of people made a few mistakes along here. A few people got it out, but you needed to have it move down along that asymptote here. It needed to cut through this point, but not touch -1, and then move along down here. So 2 marks if you got all of those, and 1 mark if you missed one. I think I was pretty nice, and if you missed a couple, I gave you 1 mark as well. But you needed to have the majority of that in there. A few people got it right but didn't have that open circle. I am not giving you that mark if you missed that open circle. primarily because I was looking for that, and that's what the HSC markers were looking for the year that was in the HSC. So they're the things that I was looking for in that question. So overall, you guys did really well. That was a question that I wanted to sort of try and separate us out a little bit with. But good job overall. You can have a look at question 7 now.